Okay, great. Yeah, you can begin. We see you see your slides, and we can hear you as well. Great.
Okay, thank you. Yeah, I'm from the University of Limpopo, so under the Speech Technology Research Group. So in our team, we have 4 members. So the main focus of our research is on 3 aspects: the ASR, which is the automatic speech recognition, the NLP, and the teacher's text-to-speech research. My focus is more on the automatic speech recognition. So the presentation today will be following the outline as indicated there. I'll start with the brief introduction and then discuss the code switching and address some of the language categories that we have. And then we'll look at the under-resourced languages. And then the focus will be on the code switch, speech and text data. And then we'll also touch on the automatic speech recognition. So speech technology is a crucial bridge in promoting the human-to-human or human-to-machine communication. As you may be aware, in the past, communication between humans and computers, it was through things like the keyboard, the mouse, and others. So as the technology evolves, the speech then became the most essential modality for human-to-machine communication. So the reason the speech becomes the most essential aspect is based on the computational resources that they've become more accessible, and also on the issue of that there's more data that is accessible, then it is easy then to develop a good speech models that can be used to enhance the human-to-machine communication. So looking at code switching is defined as the phenomenon where speakers normally use words or phrases or sentences from one language, which we normally refer to as the embedded language, in combination with other sentences in their primary language, which is sometimes referred to as the matrix language. So the code switching aspect is not a new thing. It's a concept that has been more prevalent in the linguistic field, little in the computational field. So given that now it is easy to get as much data as possible, then it is easy then to model this aspect of speech, which is code switching. However, it does have its own challenges, which I will indicate as we go along. So the code switching aspect is more prevalent amongst the bilingual or multilingual communities. So these are people who are mostly fluent in more than one language. So during their conversations, then they will switch from one language to the other. However, the people involved in the communication will then be fluent in the 2 languages that have been used, or even more than 2. So there are 2 forms of code switching. One is intersentential code switching, and the other one is intersentential code switching. Now, with intersentential code switching is when we have, during the communication, someone will then speak the whole full sentence in one language. When they move to the next sentence, then they'll switch to a different language. Now, the modeling of such a language becomes easy, because now the full sentence will be in one language, and then it is when you develop the speech models, then you can use either the LID to say which model should be used in an environment where you have multilingual models. The one that is more a bit of complex is the intersentential code switching. With the intersentential code switching, within a sentence, you can have few words in one particular language, and then subsequent words will then be switched to a different language. Now, what happens there is that the pronunciation of the embedded words normally is not, it doesn't take the the original or the native pronunciation. So if I were to give you an example, if it's a Sepedi and English, and the matrix sentence is in Sepedi, in the event that the speaker then inserts the English words, the pronunciation of the words, to some extent, will then will be influenced by the pronunciation of the Sepedi, even though the words that will be indicated there will be in English. So right at the bottom there, we have examples of intersentential code switching. So as you can see there, the first few words will be in Sepedi, and then the remaining 3 words which are colored in blue, those will be the English words. So that would then be an example of intersentential code switching. The other one there, the next one is another example of intersentential code switching. However, even though the examples I've given here, the code switching happens at the end of the sentence, is normally not the case. The switching can happen at any point within that particular utterance, either in the beginning, middle, or at the end. So what then becomes a challenge is it is not known in advance when a speaker is going to switch within their utterances, because the switch can take place at any point in time. So there are a number of reasons why people use code switching, whereas in the past it wasn't a desirable feature. But however, the code switching cannot be undermined, because it is an aspect that people are actually using, and it's not something that can be avoided or undermined. So one of the reasons is the issue of the linguistic reasons, on the basis that depending on the fluency of the speakers, then they will be able to switch between the languages. The other one is on the social aspect, whereby currently, because people are exposed to social medias, they then within their conversation, either is on Twitter or Facebook, when they write their comments, they will then be using different languages within their communication. The other one could be on the issue of cultural factors, and lastly is on the emphasis. So with emphasis is when, let's say at the particular radio station, when they announce the time, they will then indicate it in their native language. Now, because they understand that with numbers, most people will then use the English numbers, they will then indicate the very same time using the English words, such that that will then indicate the emphasis or the understanding of the term they've been mentioning. So there are a number of language categories when it comes to code switching. So before we can look at the code switching with languages, the first one before we get to the bilingual, which is the one right on top there, the yellow one. So you can actually have the monolingual. So there are about 7,000 languages in the world, and with about 2,000 in Africa. So it can be any of those languages which a person can use. When it comes to bilingual, so there are different combinations, but our focus will be on the non-English and the English. So as of course there are other combinations. So, but then in our work, our focus is only on the Sepedi and the English, not other combinations. But the categories here indicate that you can have different combinations. For instance, with the non-English and English, we can look at the African languages, the Sepedi, Xitsonga, isiZulu, isiXhosa, and many others in combination with the English language. You can have East Asian and English, European and English, and many other languages. So those are the possible combinations where people do code switching. So it's not only the non-English and English combination that you get, you can also get the non-English and the non-English. So with non-English and non-English, that's why you're looking at the dialects in most cases. So with Sepedi, for example, there are about 22 dialects of the Sepedi language. So people, if they are exposed to more than one dialect, they are able to switch between those dialects. So we have the Kolobedi, which is spoken around the Zanin area. So their usage of language is totally different from the one that is used around the Polokwane area. So now if people are then exposed to the two types of dialects, then they are able to switch between the two, depending on their fluency, of course. And then beside the bilingual, we can have trilingual. So with trilingual, then the number of languages involved, then they go to the level of 3. So it doesn't end there, it can go on, and that depends on whether people are fluent on all the languages that are being used. So the one of the aspects is that with English for South African languages is because we are mostly exposed to the English language and the native language. Therefore, as a result, those are the some of the switching aspects that we come across. So while we understand that those are the languages we have and the combinations, so the South African languages are then categorized as the under-resourced languages. So what it means is by under-resourced languages because there's limited presence on the web. So one of the languages that, or for the South African languages that is giving problem is the Indebele language. If you have to look for the presence on the web of the Indebele language, it becomes difficult to come up with that. Not only that, is because the number of people who speak Indebele, if you look at the census, it's also less. So then it becomes difficult to get such presence. The other thing is the under-resourced languages, they face a challenge in a sense that if nothing is not done in terms of preserving these languages, over time, the languages may become extinct. So then there is a need then to make sure that the aspects that are in place to make sure that the languages do not disappear over time. The other thing is the lack of linguistic expertise. So if one has to model a particular language, we'll then have to involve linguistics experts in order to assist us in terms of generating these particular resources. One of the resources, the pronunciation dictionary, which I'm going to talk about as we go along, is that one to produce a reasonable pronunciation dictionary, then we'll have to involve this linguistic expert that will indicate how words should then be pronounced. And then the other thing is the lack of electronic resources. This year we're talking about the monolingual corpora, but there are projects that have taken place in the past. One is the NCHLT project, whereby monolingual corpora was collected. So that is the kind of data that exists that we currently use in order to model these resources or under-resourced languages. The other aspect to indicate the under-resourced languages is the availability of transcribed speech data. So normally when we source the data, we can find the audio data. Now to transcribe that normally takes a lot of effort, time, and money. So there are instances whereby such data may need to be transcribed automatically, such that we minimize the challenges that come with the unavailability of this transcribed speech data. The other one is the pronunciation dictionaries. I've already indicated that to develop pronunciation dictionaries, we need the linguistic expertise. So those resources then are very limited in terms of our languages, that is South African languages. And lastly, looking at the vocabulary list. So even though some efforts have been made in order to produce vocabulary lists for all the South African languages, that is not necessarily enough if you compare it with other languages where we can get the list that are way longer than what we already have. The NCTLT project was able to produce about 15,000 vocabulary lists for all the 12 languages. But like I indicated with isiNdebele, that wasn't an easy task, but for isiZulu, and that wasn't as complex. So given those challenges for the under-resourced languages, there are ways in which we can then source this data set. But then the sourcing in this case, the one I'm going to talk about, is not on the monolingual data, but rather on the code switch data. So because code switch, while we are struggling to get monolingual data set, so with code switching, it's even more. So the challenges are then tripling. So, but then there are various ways in which we can source the code switch data. One of the ways it would be to use the social media platforms like or Facebook. Those are the platforms that one can use, or even the YouTube channels, whereby people make comments and then we can harvest that particular data. The other one would be to use the speech recording. There are two aspects here. You can either get the speech data that's already been recorded and then placed somewhere. One of them is parliamentary data. So, however, that data will then be, the domain there will be in terms of what people discuss in Parliament. It might not necessarily cover all the aspects of the code switch data that you're interested in. So it will then be a domain-specific type of data. So if you have to cover different domains, then the sourcing of the data needs to be expanded. The other one would be to use the transcriptions, depending on whether you get them on the website or any other platforms. The one that has been popular lately is the use of the news, either the newspaper news or the radio news, which is one of the projects that we embarked on for one of the students here, whereby we try to collect data using the local radio. So there we just have to look at the news that have been read on daily basis, and then we collect the data. So the challenge with the radio data is that it is seasonal, so it depends what is popular during that particular period. So your data will then be biased towards the trends within the period that the data has been collected. The other aspect is when people are engaged in a dialogue, so they were able to collect data. So any of these approaches work, but then each has its own advantages and disadvantages. So it depending on the type of data that you want to model. So, but with us, we are still using the news data. So there are a number of code switch speech corpora that have been developed. So the list that I have indicated here is not exhaustive. For other languages like the Chinese, Mandarin, and other Asian countries, they've already developed a lot of code switch data, which one can access for free. However, for South African languages, there are a few. One is the Sepedi English code switch corpus that we collected in the past. So the data is not that big, as you can see there. So the size there is about 10 hours of speech with about 20 speakers who contributed to the speech. So that is the beginning that one can use as a seed model in order to develop further experiments around the Sepedi English code switch corpora. There is another one which was developed in Cape Town, that is the isiZulu English code switch data. It's actually the three more. Is the isiZulu, isiXhosa, and then the Sesotho. So they looked at the soap opera on the television in order to produce that code switch data set. So those are some of the the work that has been done in terms of collecting this type of speech. As you can also see there, the size there is not that big. 16 hours, it's not that big, depending, looking at the computational power that currently exists in order to model any type of speech. So these are some of the things that we may need to do in order to improve the existing resources, such that the type of models that we produce should be able to match other well-established languages. So I just indicated one of the languages. This is not South African, it's French, Algerian, Arabic. So also there is a small data set which also exists. So those are some of the aspects that I can indicate, showing that there are activities that are taking place in terms of getting data from different corners of the world, but this is mostly on the speech aspect. So here I'm just showing the transcriptions that you normally get. So here is the transcription from the Sepedi English code switch dataset. So the type of data we have, as you can see there, we have the 2-character words which are dominating within the data set, which then becomes a challenge in terms of, now, if you have to model other words which are longer than the 2-character words, then the type of accuracies we get becomes less. So in terms of the type of data that we collect, there are other aspects that we may need to take into consideration. But then the Sepedi language, unlike the Nguni languages, is disjunctive. That's why you always have these prefixes that are always carry more than the other words that you can find within the corpus. So those are the aspects, but then we may not get enough information when we try to model this type of data, because the existence of different words are the ones you can get there. This is the top 20 that you can get from the Sepedi code switch data. Then beside the speech corpora, you also have the text corpora. So here I'm just listing one example, which we actually did so far. So this is the radio news corpus I was talking about. So from the news, we're able to collect about 900 sentences. Of those, we have the 22,000 words. Of those, only 2.5 were unique. Then from those sentences, we only found about 281 unique English words. So now, as you can see, the ratio of the English words to Sepedi words, this data set is dominated by the Sepedi word. Now, the reason this is the case is because the news data that we collected, our focus was on the Sepedi part. Now, what happens is that the news readers, when they compose the news, they'll always try to use as much Sepedi as possible. So even though these words have the English equivalent, so the preference will then be to use as much as Sepedi words as possible. However, if you get the English words, sometimes this will be the pronouns or the names, which in most cases the channel, the radio station chooses to use those as they are, instead of converting such words to Sepedi before they can read the news. So we did the same analysis of the radio news text as well. So the pattern is still the same. We still get the 2-character words in terms of the number of words that are prevalent within the corpus. So the challenges still remain the same. So this just to give an example of the English words that we find within the radio news. So as you can see, most of them, these are the nouns, and some of them are the names. So like Africa, Congress, and Andrew. So those are the things that we find within the radio news, because now the news readers have to use the names as they are. The other ones have been converted to Spedi to ensure that the most part of the news is read in Spedi instead. So, however, that is not all. We also have the aspect of the borrowed words. Now, what happens with borrowed words is that even though the words are of English origin, now the CV structure of the English words have to be changed in order to fit the Sepedi pronunciation of those particular words. So if you look at the first one, the private, so it's from the English word private. So then the news channel decided to write this word in this way to still keep the essence of the English word, but then the pronunciation then has to change to the South African, to the Spedi version. So the same happens with all the words that you get there. So even if you look at the million word there, so that will then be the word that is referred to as millions in English, and then now converted to Spedi has to take that particular form. So, however, in terms of the occurrences within the corpus, so we have a limited occurrence of these borrowed words. So in terms of modeling this, we may need different ways in which they need to be modeled. Because now what becomes a challenge is then there will then be, in terms of orthography, then there won't be the standard way of writing this particular word. Then how do we then model such words if we don't have the standard way of writing them? So if the others can then leave the English word using the English orthography, or others can then switch and add other things, which in Sepedi we do not have. For instance, if you look at private, the first word there, it has the character V, which in Sepedi we do not use such a character. Now we can then move on to the automatic speech recognition that now that we've looked at the resources. Now, because the work that we do at the University of Limpopo is more on the automatic speech recognition, then how do we then model this code switch speech data? So first thing I'll then define what an SR is. It's just a process of converting speech signal into its corresponding text. So what the person will then speak into a microphone, and then that particular speech signal can then be converted into the text indicating what the speaker has actually said. So for one to get that, the process that has to be followed is indicated in this diagram here. So there are three important aspects in terms of modeling the speech. The one is referred to as the acoustic model, which is right on top there. So you have the acoustic model, and then at the bottom, we have two parts, the statistical language model and the pronunciation model, which is referred to as the lexical model. So those three things are the ones which are the backbone of an ASR system. Now, in terms of resources, then it means we have to collect three sets of resources in order to develop this system. For acoustic model, then that's where we have to collect the speech data in order to develop the acoustic model. Then for the language model, this is where we have to collect the text data in order to develop this. And then for the lexical model, which is the pronunciation dictionary, there we have to then get linguistics expert to develop the dictionaries for us. Then I'll give you an example of a pronunciation dictionary as we go along. So with the collection of the acoustic, the speech data rather, so there we then have, there are two aspects, whether you want to deal with a speaker-dependent or speaker-independent type of a model. So the general SR system is mostly the speaker-independent. So we'll then have to collect data from multiple people with different ages, different variants of languages that they speak, whether they are of one dialect origin or a different one, so that we have different varieties in terms of how these people pronounce certain words within the Sepedi language. So given those people who then contributed their voices, then we're able to develop the acoustic model. So for statistical language model, the process is more or less the same, but in this case, you have to collect large text corpora. Mostly you can get that from the website, and then you harvest the data from there. So then during the decoding process, then we have a model there live. Then the person can then say whatever they want to say. We get the features extracted, the decoding process takes place, and then the corresponding text is then produced, right? So now the challenge then becomes these three nodes, the acoustic model, the language model, and pronunciation model. One of them can become the bottleneck of the entire system. So it is therefore important that every aspect should be optimized so that the combination thereof is able to produce the good accuracy that we are interested in. So now that then becomes a challenge in the sense that how you then collect these resources in order to make sure that you develop a good ASR system, it then becomes important because all these aspects will need to work together in order to get the most out of the model that you are interested in. So that is currently a challenge with monolingual corpora. Now, in modeling in the code switch one, then the challenges then are compounding. So let's start with the acoustic modeling. So there are a number of things that normally become a challenge. The one is speaker characteristics. One, it could be in terms of female and males, so they speak differently. So one of the aspects then would be when you collect the data, then you have to balance the number of males and the number of females so that you cover all those aspects. The speaking style and rate that people speak faster than others, so those need to be taken into consideration. The other aspects in terms of environment noise. So in most cases, when recordings take place, we will then prefer to do the recording within the less noise environment. But then that does not model what a typical user will then use this model for, because they will not always prefer a quiet environment to use the system. So it then becomes important that noise also has to be modeled in order to allow the models to be flexible. The other thing is in terms of channel distortion, depending on what kind of channel is being used to record the data set. So like I indicated previously that we have a number of dialects. So how do we then ensure that if you're collecting a Sepedi data with over 22 dialects in the Limpopo province, how do we then accommodate all the dialects so that the system can be accommodate different speakers within the very same language? Because when you speak of Sepedi, we don't necessarily refer to a particular dialect. So we're assuming that any person who speaks Sepedi, irrespective of the dialect, should be able to use that system. The other challenge is in terms of non-native accents. Those who are not native Sepedi speakers, how do we then accommodate such accents in order to make use of the system? Now, when it comes to pronunciation modeling, so in code switching, so if we have the English words, how do we then model these English words? So there are a number of ways in which the English words can be modeled. One is you have the English word pressure. So then the pronunciation of that particular word will be the sequence of phonemes as you can see there. So now, like I indicated when we started, was intrasentential and intrasentential. Now, if you have with intersentential, it might not be a problem because a person might say the English word using the correct English pronunciation. But then when it comes to intrasentential code switching, what then happens, because now the word might be influenced by the neighboring words within the Sepedi language. So we can then add an additional pronunciation of the word pressure, which is in English, but then with the Sepedi version. So the one on the right there will then be the Sepedi version of the pronunciation pressure. Now you can have the two pronunciations within the same pronunciation dictionary in order to model the word pressure. So it is not limited to this because there are a number of ways in which you can model this English word. Now, if you just add the English pronunciation and Sepedi pronunciation, now the complexity of the dictionary then increases in a sense that you have the Sepedi phonemes and the English phonemes within the same dictionary. So now the number of phonemes then increases. So you're moving from 45 phonemes to and add others which are from the English, which were not there for the Sepedi original phonemes. So then the confusion rate then it also increases. The other approach will be you can then use the IPA to map the English phonemes to the Sepedi phonemes so that in the dictionary you only have the Sepedi phonemes and you do not have the English phonemes in order to minimize the confusion rate. So those are some of the aspects that can be taken into consideration trying to model the pronunciation of the English words given the existence within the Sepedi utterances, such that we're able to figure out how well to model those particular words. So that would be on the aspect of the pronunciation dictionaries. So in essence, therefore, it then means if you have to develop the code switch SR systems, now there are linguistic variations that have to be taken into consideration. So we've already touched on those linguistic variations in terms of dialect and other aspects. So we already know that there's limited code switch data that is available out there. So now with the little that exists, so how do we then work with that in order to develop good code switch SR systems? So we're going to look at one of the or two aspects that you can take into consideration to address the lack of code switch data in a moment. So the one that still remains a thorny aspect is the standard orthography. So like I indicated in the previous table, if you have English words within the Sepedi utterances, the orthography depends on the person who is transcribing the data. That those will then write the English words as they are. They're the ones who will transform the English words into something that is closer to the English version by changing the English structure into the Sepedi CV structure so that it meets the pronunciation that a typical Sepedi person will actually say. But then
just the 5-minute warning there, just to give it
okay.
Yeah.
Okay.
Thanks.
Yeah. All right. Thank you. So then the standard orthography then becomes a challenge which we need to deal with. So what do we have identified so far? If you are collecting the Sepedi corpus, in most cases, because of the environment that you are collecting the data from, always have the limited English words. You also have the challenges with the borrowed words and the size. In most cases, the size of the corpora is always small, like we indicated in the previous table when we were showing the number of sentences for radio news. We had about 900 sentences there. That is not enough, especially if you have to use, let's say, neural networks in order to develop these models. They are data hungry, so you need to provide a lot of data there. So to deal with the limited data set that we have, there are a number of approaches. One is that we can use text generation approaches. Currently, people are using the transformer models in order to generate the syntactic data. So that data should model more or less what a typical human being can produce in terms of type of text data that we can use probably to develop the language models, because with language models, we need huge amounts of text data. So if we can't get it elsewhere, then we have to generate our own, but it must model what a typical user can say. The other one would be data augmentation. You can do it both with speech data or text data, find ways in which the data can be duplicated so that we have enough data to take care of those challenges. So here, these are some of the articles that I used to produce this slide. These are them. You can go through them to see how people collected the data. The one at the bottom right, that is the Sepedi English Code Switch corporate that we produced. And then the top left is the one for the radio news, the Sepedi English radio news. On the right-hand side, we have the Uvzela tool that was used to collect speech corpora was developed with the CSIR. And the type of data that was produced is the NCHLT, which is mostly the monolingual data that we normally use to develop the speech models. So in conclusion, code switching, as indicated, is one of the complex phenomena because of the way in which people use code switching, depending on the number of reasons that we indicated, whether social or linguistic. So, however, code switching, it is a relevant aspect given the nature of the languages that we're dealing with. So with under-resourced languages, we are bound to find ways, people communicating by switching between different languages. The other thing is data sparsity remains a challenge, like we indicated, in terms of variability of speech and the orthography thereof. So that brings us to the end of this presentation, and I thank you.
All right. Thanks very much, Thipe. Maybe you can stop sharing your screen. I think that you covered a kind of a lot in there, also giving a lot of historical context inside in terms of in this work. And maybe to kick it off, while people are getting ready to ask questions on there, please, if you want to ask a question, just virtually raise your hand, and then I'll acknowledge you, and then you'll be able to unmute and then ask your question. But I wanted to ask, in terms of now, we have this thing where it's either like, go big in terms of data and then building these big transformer models, or go home. And I wanted to find out, like, what are your thoughts in that space, given kind of where we are and your experience in within this area. Yeah.
Thank you. What we have found so far is that we first had the fear that transformer models may not work for our languages given the size of corpora that we have. But the experiment that we conducted, we were shocked to realize that even with limited data, if you take the pre-trained models and then we use our limited resources, we still can produce reasonable model. So the example that we did is the text generation model using the transformer approach. When we checked the text data that was produced, we were able to produce meaningful sentences, even though the sentences, in some instances, they may not make sense, but then in terms of the sequence of words, how one word follows the other, so those will then make sense. But in terms of the meaning of the sentence, that may not be what we're looking for. But that is a start, because given the size of the data that we have. So the plan then will be, as we increase the data set using the method that I've indicated, that is the synthetic approaches. So we may then produce the synthetic data, retrain the models, and see whether we'll get some gain from there. So those are some of the things that we are trying to do to see whether with synthetic data can we get somewhere or the model will be completely lost. So those are some of the things we still have to figure out what is happening in that space.
Okay. No, thank you. I think Onyoti has a question.
Yes, thank you so much, Fukosi. Thank you, Prof. Thipe. Great intro to the session. I have two questions. The first one was on the example you gave on the intra code switching, where you had a full utterance and you had different dialects. How do you handle that? Because then it would seem like a mixture of both switching and mixing. So how do you handle that part? But also, how are you able to detect the different dialects of Sepedi in an utterance? Sorry for the background noise. In the languages that you're working on, when you looked at the combinations of non-English to non-English dialects, you had 22 dialects of Sepedi. So how are you able to identify, be it your models, to identify the dialects and the languages that they're working on?
Okay, there are two aspects. One is on the orthography side. So even though there are 22 dialects in Sepedi, so in terms of the writing system, all the Sepedi or Sepedi in essence, we use the same writing system. The orthography is the same. Now, when we do the text modeling, so we just use the Sepedi orthography that is the standard one. Now, when it comes to speech data, unfortunately, that is a complex aspect that we have not embarked on to see whether we can model speech data given the different dialects. So the data set that has been collected so far, it only focused on one dialect, which is the Polokwane area, the central Limpopo, to collect the speech data. Other dialects of the Sepedi were not considered. So we haven't taken that route to model different dialects of Sepedi. We just acknowledge that those aspects exist, whether within this, the data set that we have different dialects that has not been modeled. So it's something we may need to consider maybe in future, but unfortunately, we haven't gotten to that level as yet.
Okay. Thanks on there. Okay, I think Helena says fingers crossed for the synthetic data. There's a question from Michelle here, says for the isiZulu and the other three languages corpus, they use synthetic generation to augment the data and show improvement in ASR models. What are you taking from that? And then what kind of methods are you currently using to synthetically generate data? And then how did you evaluate the text that was actually generated, whether it's good or bad? And there's a lot of questions on there, but you can you can take it in pieces. I guess it's in the chat.
I'll start with the second part. We haven't really evaluated the generated text. So the researcher by himself, so he just reads the sentences that are read without using any metrics to measure the accuracy there, whether using the code mix index. So all those aspects we haven't used to determine the accuracy of the generated text. So we still have to go to that route. We just generated the text. The researcher reads the sentence to say, do they make sense or do they not make sense? So the next step will then be to get participants. So there are two aspects. It will be the intrinsic evaluation and extrinsic evaluation. With extrinsic, that's when we invite people to say, given these sentences, what is your view on the sentences that are being generated? Then the intrinsic one, that's when we're going to use the other metrics in order to check the accuracies of the generated text. So the synthetic data, yes, what has been found is that there are experiments that were conducted in the past whereby they were comparing what the difference between a synthetic data and what a human being can produce in terms of a code-switched utterance. So it has been found that the machines can actually generate more sensible code-switched sentences compared to human beings. So I just I don't have the reference with me at the moment, but yeah, but that wasn't for South African languages. I think it was one of the Asian languages whereby they were comparing the synthetic sentences versus the ones that human beings can actually produce in terms of the switching between the sentences. Thank you.
I'm saying thanks on there. Coyote, you can unmute and ask your question.
Thank you very much, Thipe, for your talk. So there are lots of data sets, code-switch data sets online, like on YouTube, podcast. And what is your take on leveraging advanced ASR system to extract this data set?
Yeah, I think the existing data sets have actually helped in terms of assisting in terms of modeling the type of data that we are dealing with. In terms of text generation, there's one approach. Was that transfer learning, whereby you take the information from well-resourced language in order to boost the under-resourced language. So those type of transfer learning approaches have seemed to work well so far. So those are some of the things that we may need to go further and experiment when it comes to our South African languages, which we haven't explored much so far.
Okay, thanks. Helena, you can finish.
Thank you. I'm very curious about the relationship between code switching, from a purely linguistic point of view, as you described it to us, and translanguaging as a pedagogic intervention. How do you see the relationship between the two? And do you think that the growing popularity of translanguaging as an empowerment structure will help generate data for you?
Yeah, I think that can actually help, but then, yeah, because I do not have the linguistic background, so I might not have enough information around that. So I come from the computer science background where we just model the existing data. So in terms of whether that will help, it's something that we may need to explore given an opportunity. But yeah, at the moment we haven't explored such an approach that we may need to figure out whether that will help or not. Thank you.
Okay, thanks, Sander. I think there's some last questions here from Munyoti on, again, there's a few questions and then you can see them in the chat. Did you encounter license issues with the radio data? What licenses issues might you think about for YouTube and social media? Are people most likely to code switch or code mix? In South Africa, and should you invest in either getting a code switching data set or a code mixing data set? There's a lot of questions there.
Yeah, of course, investing in that will be very important because there's lack of data when it comes to code switching. Whatever method and approach you can use, that will be great. But in terms of licensing issues, the radio station that I was referring to, that is a local radio station. We got an agreement to actually use their radio news. So we do not have licensing issues there. They're the ones who are actually giving us the data directly. So we have a mutual understanding around that. Thank you.
Okay, and then I guess I think there was a in between question, like if you were to build a data set, would you do code mixing or code switching?
For us, code switching and code mixing, we're using them interchangeably because, like I indicated, since I don't come from the linguistic background, for them those two are different concepts. But for us, for as long as there's a switching between the two languages, we use code switching and code mixing interchangeably. Could mean other things for linguistic.
Cool. No, thank you. Are there any last questions? We are about to finish off within there. I guess going once, twice, thrice. I really want to thank Thipe for this talk, and I think it's a burning issue in terms of in the area. I think that's why we have a lot of very active people who joined in today as we're thinking about the future. In some ways of languages, yes, we might come from computing or mathematics, but there's a lot that people are trying to do within this area, as you can see, and I do hope people see themselves in the things that they could be doing and assisting in this area. Do reach out to Thipe if you want to have a further conversations with him on there. I think his email is public, likely somewhere on the University of Limpopo website on there. And thanks for coming through and spending parts of your Friday with us on there. We've got 2 more seminar talks, hopefully not one, for left in this year, and we hope to have you in the future. Thanks, and enjoy the rest of your Friday, and see you guys and see everybody next time. Thanks, Thipe.
Thank you so much. Cheers.